Alright, let's take a look at our monster problem. This is the one that students really don't tend to like that much, although I think it's kind of fun because if you want to get good at algebra, this is the one you want to do. Now note I'm going to rewrite it. The top is cotangent of x plus 1. The bottom is my x to the 1/4. You want to write this at, you wouldn't use quotient rule for this one. It's going to look really, really super ugly, but I promise you it's not as bad as it will seem. You can get really good at doing algebra in your head. So when I take my derivative, I'm going to use my rule. Okay? The derivative cotangent, we're going to talk about this in a second. Okay? We're going to talk about the derivative cotangent in a second. So right now we don't know this, but I'm going to pretend like we do. We're going to get, this becomes low x to the 1/4 times d high. Now the derivative of cotangent, we're going to talk about this as negative cosecant squared of x. So low d high minus, whoops, the one just goes away, minus high, which is cotangent of x, plus 1 times the derivative of the bottom. And this is where it gets a little bit tricky. We're going to get 1/4 x to the negative 3/4 all over the bottom squared. Okay, so this is my derivative right now. And it's pretty ugly, okay? I'll admit, that's really ugly. But we're going to start cleaning this up. Anything that has a negative exponent, remember, I don't like that. That's what I got to get rid of. This is the no-no right there. So this is going to leave me with, if I simplify it, I write a big fraction bar. The only thing on bottom is this x to the 2/4. So on the top here, I'm going to get this negative x to the 1/4 cosecant squared of x minus, but over here I have a gigantic fraction, so I'm going to do another fraction right here. On the top, I'm going to have my cotangent of x plus 1. On the bottom, that comes from over here, I'm going to get this 4x to the 3/4. That's pretty tough to get, so convince yourself that that's okay. The only thing that's really weird right here is that cosecant squared. We're going to talk about that in just a few moments. Now we have what's called a complex fraction, and you're going to do all of this in your head. To get rid of this, we're going to multiply by what we call that LCD again, and that is this 4x to the 3/4. 4x to the 3/4. I'm going to multiply everything by that, and I get this fraction on top. If I multiply over here, I'm going to get negative 4. Now take a look. I have x to the 1/4, x to the 3/4. That just becomes x to the 1st. And don't forget about your cosecant squared of x. Minus, and I'm going to distribute to here, but over here the x to the 3/4 will cancel. And that's just going to give me this cotangent of x plus 1. Don't forget, there's a distribution there, so don't forget your parenthesis. And on the bottom, ready, we're going to get this 4x, and now I didn't reduce it to 1/2 if you notice. I'm just going to add those together, and I get 5/4. And that's your answer right there. This is kind of a weird one, so convince yourself on this one here, okay? But right now what I want to take a look at is a note card. I want you all to get a note card today, okay? And on the top of here, we're going to write down our derivative rules. Okay? The first rule that we learned was that power rule. And that was if you have f of x equals x to the n, then the derivative f prime of x was nx to the n minus 1. The next one we have is our product rule. And that says if h of x equals f of x times g of x, then we can say h prime of x is the first, f prime times the derivative of the second, so the first, excuse me, it's terrible, the first times the derivative of the second, plus the second times the derivative of the first. That's an x. Next we have the quotient rule. And that is the following. If h of x equals f of x divided by g of x, then we can say h prime of x is low g of x d high f prime of x minus high f of x d low g prime of x all over the bottom squared. Now there's going to be another one we're going to talk about, chain rule. I unfortunately didn't give myself enough room, but we'll put that on the back. But you want to have these, okay? Not for a test or quiz, but you want to have those on a note card. So on the back, we're going to leave a little bit of space here for something called the chain rule. I am, at least. Okay, we'll talk about that. That's later on this week. But down here, I want to do all the trigs. We know that the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. You might recall we did the derivative of tangent of x, right? The derivative of tangent of x, we did that over here on the other side here. Hold on here. We did the derivative of tangent of x, and we got that with secant squared of x. Likewise, if we took the derivative of cotangent of x, and we just talked about this, right? We mentioned this in our notes here. Hold on here. We mentioned that in our notes that the derivative of cotangent, we just said that was negative cosecant squared. So that's negative cosecant squared of x. So you have to memorize these. And there's two more. The derivative of secant of x is secant x tangent of x. And you can verify these because I can write secant of 1 over cosine of x, right? And I can just, if that's f prime would equal, just find that derivative. And then the derivative of cosecant of x, well, sine became cosine became negative, tangent was secant, cosecant becomes negative cosecant. So if secant is secant tangent, cosecant is going to give us negative cosecant of x, cotangent of x. Now, what I like to say is the co's co-negative. It just sounds kind of cool. Co's negative. Co's negative. So all the co's become negative. So you have to memorize all of these, okay? And by your next quiz, by the way, so make sure you get that done. All right, now there are exceptions to the product and quotient rule. I could use the quotient rule for like number 5 right here. But because it's only a single term, I can just bring that power up. And I can just write this as 5/3 x to the negative 2. And I can just use my power rule. And if I bring down my power, this becomes negative 10/3 x to the negative 3, which is just negative 10 over 3x cubed. And there's our derivative right here. I should say f prime equals that. There we go. Likewise here, again, I could use quotient rule here, but we talked about this one. I could just really here, just split the fraction. In other words, I can write this as f of x equals 3x squared over x plus 4 over x. And I can reduce that. 3x plus 4, remember we don't like x to the bottom. Bring it up. And taking the derivative, we get 3, use your power rule, minus 4x to the negative 2, or f prime of x equals 3 minus 4 over x squared. Now, I went really slow with this, but I promise you, you're going to get really good at these derivatives right there. Okay, hope you guys enjoyed the videos as much as I enjoyed making them, and I'll see you guys later. Bye.